have been caused by a giant, ancient, mysterious monster. What is this monster we call infinity? What do we mean when we throw around the innocuous-sounding word forever? In our modern, impatient world, people are prone to use it rather hyperbolically, exclaiming, "I've been on hold forever," after 2 minutes, or "This web page is taking forever to load," if it takes more than about 3 seconds. I'm told by Basque writer Amaya Gabanso that in Basque the word for 11 is hameka, but it also means infinity. This is borne out by another friend of mine who did an audit of homemade jam in the cupboard and declared there were 4 jars from 2013, 10 from 2014, and lots from 2015. Apparently, more than 10 might as well be infinity. My research field is higher dimensional category theory, and there, higher usually means 3 dimensions or more, including infinity. Everything from just 3 to infinity turns out to be about the same. The way we think about infinity in our normal lives might be dreamy and exciting, but it dissipates under close examination, like the end of a rainbow, which will never be there if you try to go looking for it. It causes paradoxes and contradictions, impassable ravines and murky traps. It doesn't stand up to the tests of rigorous logic, as we'll see. One of the roles of mathematics is to explain phenomena in the world around us, especially phenomena that crop up in many different places. If a similar idea relates to many different situations, mathematics swoops in and tries to find an overarching theory that unifies those situations and enables us to better understand the things they have in common. Infinity is one of those ideas. It pops up all over the place as an idea that we can dream about, and seems similar to other ideas that can be unified by mathematics, the ideas of length, size, quantity. So why is it so difficult to extend those easy mathematical concepts to include infinity? This is what this book is about, why it is difficult, how it eventually can be done, and what we see along the way. Infinity instincts. Infinity is easy to think about, but hard to pin down. Small children can quickly latch on to the idea of infinity, but it took mathematicians thousands of years to work out how to explain infinity in full technicolor logical glory. Here are some things we might think about infinity. Children come up with these thoughts about infinity quite often, all by themselves. Infinity goes on forever. Infinity is bigger than the biggest number. Infinity is bigger than anything we can think of. If you add 1 to infinity, it's still infinity. If you add infinity to infinity, it's still infinity. If you multiply infinity by infinity, it's still infinity. Children can get very excited when the notion of infinity first dawns on them. They learn to count up to 10, and then 20, and then they learn about 100, 1,000, 1,000,000, 1,000,000,000. If you ask a small child what the biggest possible number is, they may well say 1,000,000,000, but then you can ask them about 1,000,001,000 and watch their eyes widen. It's not very hard to convince them that no matter what number they think of, you could always add 1 and get a bigger number. This gives the idea that there is no biggest number. Numbers go on forever. But then, how many numbers are there in total? The idea of infinity starts to emerge. Perhaps some children first hear of infinity because they watch the Toy Story films and they hear Buzz Lightyear saying, "To infinity and beyond," which does sound very exciting. When I was a child, Toy Story hadn't been made yet, but I had inklings of infinity from the loops I described earlier, the physical loops in our house and the abstract loops in my favourite computer program. Once children start thinking about infinity, they can easily come up with questions about it that are teasingly difficult to answer. What is infinity? Is it a number? Is it a place? If it's not a place, how can we go there and beyond? If children hear about infinity at school, the questions just start proliferating. Is 1